Two of the following videos are true, while the other one is trash. Can you spot the fake? Round 2, let's begin. First, take a glow stick, crack it, swirl it around a bit, and then cut it open. Next, pour the liquid into 2 different beakers, and you'll see that both will glow at roughly the same brightness. Next, take an ice cube and place it in one of the beakers and stir it up. After a few moments, you can clearly see up close that the beaker with the ice cube will glow much brighter, although it won't glow for as many hours if you do this. Here's a 3D printed structure with a nut glued to the top so I can thread a bolt on and twist it to adjust the height of the bolt. Next, I'll take a strong neodymium magnet and place it on the head of the bolt. Here's a tiny cube magnet that will of course be attracted to the magnet that's attached to the bolt. Next, I'll take 2 solid bismuth cubes and stack them on top of each other like this, leaving a small gap between them. If I place the cube magnet between these cubes, it rests on the bottom since the magnet isn't close enough. However, if I twist the bolt to lower the magnet to just the right height, the magnet will be lifted up and levitate between the 2 bismuth cubes, as you can see here. First, take a long skinny balloon like this and stretch it near the opening. Then fill up the balloon with a small amount of air and tie off the balloon. Then tape the balloon down to the table. Next, on the other side, grab a section of the balloon and stretch it out a few times to weaken the balloon in that spot. Now if I grab the air pocket and squeeze it from all sides with a closed fist, the air pocket will immediately jump to that spot that I stretched out on the balloon. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. If you thought you could use 2 bismuth cubes to levitate a small magnet like this, well done, because this is legit. Bismuth is a material with a really strong diamagnetic force relative to others. Diamagnetism is a repelling force that is typically quite weak. However, as I've shown before with graphite, which is another material like bismuth that is very diamagnetic, a very thin piece of it can be repelled by magnets and levitate. However, that's because it's so thin and lightweight that it can overcome the force of gravity on its own. This cube magnet is much heavier, and the diamagnetic force is not enough alone to levitate the magnet. That's where the top magnet comes into play. When the top magnet is close enough, it will lift up the magnet. However, I don't just want it pulled up, I want it to levitate, which is where the second bismuth cube above it plays a role. With that cube on top, there's a weak diamagnetic force repelling the magnet in both directions. Then once I lower the top magnet enough to roughly cancel out the force due to gravity, now the diamagnetism has the predominant impact. It's cool how stable it is, and I was actually made aware of this from this structure that I bought, which works the same way. This structure was one of the products in my Cool Gifts for Science Lovers series that I do, so check out that video to see many more cool options. Anyway, stretching a portion of the balloon on the other side of an air pocket does allow you to squeeze it and immediately send it to that spot. You don't have to tape it down, and you can keep squeezing each side to send it back and forth. Placing an ice cube in glow stick fluid does not make it glow brighter. I actually added a bit of dish soap to the ice cube while you weren't looking. It's actually the dish soap that makes the glow stick fluid glow more brightly.